Okay, this looks like a very complicated definition. Let's break it down because it's not. The numbers in front, the coefficients in front of the x, these are all real numbers. So any number you know pretty much can go in front, just not imaginary numbers. But here's the key. N, or the exponents, exponent here is 1, exponent here is 0, can't be negative, but they have to be integers. Sounds like whole numbers to me. You can plug in anything you want to for x, so the domain is all real numbers. Plug anything you want to for x. And this guy, which is the first one, is the first one, called the leading or first coefficient. So for this example 5, we don't worry too much about the numbers in front, even if they're decimals or if they're decimals here. But the issue, the big issue, are the exponents. And the exponent here is the one that's no good. Otherwise, the other exponents are fine. They are non-negative integers or whole numbers. So are these polynomial functions? The key again will be the exponents. The exponent here of -1 is no good. This x is in the bottom. It's kind of like a -1 exponent, so that's no good. Here we have an exponent of a decimal. That's no good. But all the others are fine. For those that are polynomials, they ask us to give them the degree. The degree is the highest exponent. So 2 here, 2 here. The 3 here, it's like x to the 0, because anything to the 0 is 1. So the degree is 0. Here it's 3. Here it's 1. If I were to multiply this out, I'll get -6x to the 8th, blah, blah, blah. And here again, x to the 0 is missing, but I can provide it. And so I get a degree of 0 for that as well. If we were to graph polynomial functions, they'll be nice and smooth. They won't have a break, and they won't be jaggedy with sharp corners. Now the idea of n behavior is this. This is the left side, it's going down. This is the right side, it's going up. This is the left side, it's going up. This is the right side, it's going up. What's happening at the left end and the right end? Well, we can see from the graph, but if we have the polynomial equation, which is back here, without the graph, how are we going to tell about the left and the right-hand side? Well, here is that first term, the leading term. This is the leading coefficient, and this is the highest exponent. So, if the leading coefficient is positive, greater than 0, the right hand's going to go up. Right, x goes to infinity. Up, y goes to infinity. If the number in front is negative, less than 0, then the right hand goes down, and right means going to x goes to infinity, but down means y goes to negative infinity. So right hand up, right hand down. Now to determine the left hand behavior, we look at the exponent. If it's even, the left hand is the same as the right hand. So if the right hand goes up, the left hand goes up. If the right hand goes down, the left hand goes down. If the highest degree is negative, odd, if it's odd, then the left hand is opposite the right hand. So if the right hand is up, the left hand is down. If the right hand is down, the left hand is up. You have to do the right hand first. So for example 7, we have some mysterious mystery graphs. And we look at little Roman numeral 1. If we were to multiply it out, we're going to get negative x cubed and some other stuff. Well, third degree means the ends are the opposite. So it could be C or it could be D. But since the leading coefficient is negative, the right hand goes down and the left hand goes up. And that's C. This is the first term, and so 5, the right hand goes up. 4, it's even, the left hand is the same as the right hand, and so A looks very promising. And this one, this is 5x plus 15 minus 5x. Simplifying this just 15, and remember that if y equals a number, it's always a horizontal line. And so that's B. The one we didn't choose was D, and so we can though tell you what's going on with that one. The right hand goes up, so the leading coefficient is positive. And the left hand goes down, so that means that the degree has to be odd because the left hand is opposite the right hand. Now, this is very silly, but I could write odd as O, T, D, and you flip it over, it's O, P, P for opposite, if that helps you remember that odd is opposite. So for example 8, the leading coefficient is negative, so the right is down, right, down. And the exponent is odd, so the left is the opposite, or up, left, up. The other three are similar. Just know that if you multiply out C and D, all you have to do is multiply out and imagine what the first term is going to be and ignore everything else. Do you see that for C, the first term is going to be negative 4x to the 6th, and for D, the first term is going to be 2x to the 5th. Just imagine multiplying it out and just taking the highest degree term.